This video will just provide a quick overview of a Unix shell clone that I've built. And so essentially this is a Unix terminal and it's used to access the operating system services that we all know and love. And so this was created to learn about systems programming and things such as how to balance multiple processes, resource management, and inter-process communication. And so I can sit here and read the README word for word, but that's pretty boring. So let's just see it in action. The project has its own make file, and so we can just compile the program and generate an executable pretty easily. So if I just type make, it's going to go ahead and compile the program for me, and it generates an executable called Unix shell, and I can just run that. And awesome, we're in. And so now I'd just like to go through a few examples of what the shell can actually do. First off, you can expect it to run any regular Unix command that you would normally use in a terminal window on, Linux or Mac. And it does this by cloning and spawning child processes from scratch. And so this is actually the exact foundation that Unix was originally built upon. So we can expect a shell to run things like ls, list out the context in the directory, also something like sleep for 3 seconds. That's also possible here. The shell can also handle file redirection. So I have this file here called test. And if we look at what's inside of it, it just says hello world, this is a test. And so here, the cat command by default routes the output to the command line. And we can actually write it using the right caret key to any other file. So let's just call a file test output. As we can see, there's no output in the shell, but if we look into the contents of test output, we can see that it was successfully written. We can also handle file feeding. And so usually you would see people do something like ps, and then you would pipe it to a grep command, and then blah, 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 and then you would grep something here. And so this shell just has a simpler syntax, so we can do grep world. And so the grep command just looks for the word world and returns the lines that match that word. So in our test file, we expect hello world to come back from this. So we can feed it our test file using the left caret, and then we can write those contents to a file, let's just call it grep output. And so again, if we look into the contents of grep output, as expected, we get hello world. And so the shell also has some built-in commands such as jobs, which is just a glorified PS command basically. And so here it lists things such as the PID, the status, and the command that was actually executed, along with the number of processes that are actually active. And lastly, I also have a short C script here called sleeper. Essentially, what this does is just asking for the computer to just sleep for 15 seconds. And so it's doing something like this, except not 5, but for 15. As you can see, my hands are kind of tied here as it's running in the foreground, and I can't really get any work done. And so what we can actually do is run the program, but we can send it to the background using the ampersand character, which is standard syntax amongst Unix shells. And so when I do this, we can see that I can still do whatever I want, and the task is running in the background. And if I run jobs again, we can see that sleeper is indeed running. And I can do something like suspend it. And so here, using the suspend keyword and the PID, I've suspended the process, so it's now paused in its execution. I can also resume it, doing the same thing, just using the resume keyword. And I can also kill processes. And all those work flawlessly. And we can also exit the shell simply just by typing exit. And upon exiting, it just spits out a little summary of the work that we've done during the session. And so the commands that we execute were pretty lightweight and quick. So the numbers here are still stuck at 0. But you can expect these numbers to increment if you're performing any CPU intensive tasks. And so that was a quick overview of this project. All the code for this is available on GitHub. And thank you for watching.